I am a visionary. Illuminating galaxies to witness the birth of stars. And sharpening our understanding of extreme weather events. I am a helper, guiding the blind through a crowded world.
I was thinking about running to the store.
And giving voice to those who cannot speak.
Do not make me laugh.
I am a transformer, harnessing gravity to store renewable power. And paving the way towards unlimited clean energy for us all. I am a trainer, teaching robots to assist, to watch out for danger, and help save lives. I am a healer, providing a new generation of cures and new levels of patient care.
Doctor, that I am allergic to penicillin. Is it still okay to take the medications?
Definitely. These antibiotics don't contain penicillin, so it's perfectly safe for you to take them.
I am a navigator, generating virtual scenarios to let us safely explore the real world and understand every decision. I even helped write the script. Breathe life into the words en muchos idiomas y escribí la música. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
So, buongiorno. One of the things you'll notice is I don't speak Italian, so I hope you'll understand my somewhat limited English. I've just spent a week in Calabria, so I've learned a little bit of Calabrian, but I've just also realized that's not Italian. So, can you run the slides, please? Thank you. So, it's compulsory when you're in video. If you're going to do a keynote, you have to have a video. So, I chose one that came recently, presented by Jensen Huang, our chief executive, at a couple of our events recently. And I'm going to talk a little bit about, for the next 15 minutes or so, about changes in the industry, the emergence of what we see in what we call AI factories. Now, the European Union made some substantive changes yesterday to its structure of its commissioners. And one of the things they announced, it has a new commissioner looking at all the impact to look with AI. So one of the things that the European Union is sponsoring is this emergence of AI factories and what that means. We'll talk a little bit about that. We'll talk a little bit about Gen AI, beyond the hype cycle of actually moving in production. And I'm going to talk a little bit about our next generation of products, which is shipping shortly, which is going to again revolutionize the way we can adopt this technology as quickly as possible. So firstly, I'm going to start with a bit of a history lesson. Now, despite my youthful good looks, I actually go back quite a long way. I don't go quite, 1964 was the year of my birth, so I don't quite remember the System 360, but in the 1990s, I remember System 370 mainframes. And then we went through this whole succession of where we are. 2 weeks ago, I was in the US and I went to a workshop with Jensen Huang for 2 days, which is probably the longest 2 days of my life, with the most demanding individual on the planet. But one of the things that he meant, the message that we all had to hear is, remember that you are here at this moment in history. And that sounds like a bit like, what do you really mean? He said, yeah, people have no concept of what is going to happen in the next 5 to 10 years. It's going to transform everything they do from their daily lives, and they have no concept of it But just remember to tell your grandchildren that you were there when it happened. So a very important phase. But we're now reaching this phase of where we started to see generative AI models, startups, and we're on to the next stage of what we call the new industrial revolution. Now, NVIDIA's come on board from this. We provide a complete platform from the whole area, from hardware layer on the bottom, and it's not just about hardware. Hardware on its own doesn't fix the problems, as many of our competition is finding. You have to add on to that a series of libraries and software capability, and on top of that, you have to then have a series of models that enables people to deploy the technology quickly and efficiently. And that's what NVIDIA brings as a total solution stack towards delivering generative AI and AI solutions. Now, we've seen this concept, as I mentioned, of this AI factory. Now, people have come from the model of having a software factory where you take things to go and you go and develop software and it comes out of it. One of the things that people were concerned about with AI is the future of programming wouldn't exist, because you can use an AI tool to program and develop programs for you and turn everybody into a programmer. Now, the reality is somewhat different. The people who've made more use of the AI tools are actually experienced programmers. And those experienced programmers have gone in and learned that actually all those mundane pieces of programming that I do, that I really hate doing, that take forever to do, I can outsource to a GPT or a model, and the things I can work on is the things that's more exciting, more interesting to program. And you've seen programmer efficiency go up by 1,000x. So we've moved from the concept of basically software factories to the concept of an AI factory, where you bring together skills, GPUs, models, and the AI factory is now becoming for governments the critical infrastructure for the future. Now, you can't pick up the newspaper in any country in Europe without reading something about the lack of growth in the European economy. I read it this morning in the Financial Times. I was coming about Europe is facing it, UK is facing it, everywhere is facing this lack of growth. And the governments have cottoned on across the world that the AI factory is the new critical infrastructure. It becomes a new instrument for scientific discovery, but also an engine for economic growth. Now, for years, people have been trying to take HPC, which is a complicated set of technology, and apply it to other industries without a huge amount of success, mainly because the amount of skills and knowledge you need is extensive. But what they're starting to see is people are starting to do AI spin-ups in every country in Europe. We've already seen successful companies come out of France, like Mistral and Hugging Face. We're seeing iGenius as an emerging company coming out of Italy. And we're seeing this all over Europe, where entrepreneurs and skilled people are developing new startups that are going to be the future economy of Europe. So we're starting to see governments recognize this as an engine for growth, and also a platform for public sector innovation. So I can deliver services to the public in a more efficient manner by using generative AI and improve access to services, as well as improving those services to the consumer and to the citizen. So what we're seeing with this AI factories concept is basically the summary is on the top there, really. People are looking at this concept. This is a slide that came out of the EU's presentation. And what they're trying to do is to say, we've recognized that having big, solid national computing centers is a good thing to do. Cineca is a great example in Italy, outstanding success, one of the leading centers in Europe. But across there, if I can use those centers to also help me kickstart my economy and enable startups to go and come into that environment and test and scale their code, it helps me generate and grow my economy. Now, Jensen Huang said to us 2 weeks ago, he said, when I started off founding NVIDIA, it was really easy. I had a great idea. It didn't sound easy, but it said it was easy. I had a great idea. I went to see some venture capitalists. They gave me $10 million. I was up and running. He said the problem for AI startups today is that if you're trying to run a model and improve something, you have to be able to run it at scale. You have to be able to prove it will scale. You have to be able to prove your application will work. And most of the startups cannot afford to go to Amazon or Google or anybody, frankly, and say, please, can I have 1,000 GPUs or 10,000 GPUs to scale my code? And oh, by the way, I'd like to not pay you anything. Yeah, it doesn't quite work. So what the national governments are recognizing is if I have this investment into large GPU centers and GPU environments, what I can do is bring these organizations in and enable them to scale and develop their code, enable them to get it to scale to 1,000 GPUs, 10,000 GPUs and beyond. And a good example of this is Mistral just did their Bio Mistral, which is their bio version of Mistral, was tested completely at the Gen C Jonzé supercomputer in France, a publicly owned asset. They used a scale of a number of 200 GPUs for a number of hours to help scale and develop their code. And that's really the model where AI factories are going to go. We've also seen this concept of the emergence of digital twins. And this is where people are using technology, and one of the examples of this is NVIDIA Omniverse, to enable them to build a model of what the future should look like. And here's a couple of examples I'm going to show you. The first one is from Kenmac, which is a warehouse ecosystem. And this is showing a digital twin of what a warehouse ecosystem should look like. Amazon has something similar, many of them have the same sort of concept. So when these guys open a new warehouse to put all these goods in, because nobody shops in retail anymore, everybody shops online, right? Well, if you're going to do this, you need to have some sort of infrastructure of how it's going to be planned. How are you going to store things? How are you going to get things moving? How are you going to pick it? And what people are doing is building a digital diagram of what the warehouse should look like before they're going to implement it. And they can optimize routes for robots. They can optimize routes for shipping out of that digital twin. Another example, this is from a factory ecosystem. I'm going to show you a few examples here. This first one is from Foxconn, where you're actually going to see the use of robotics, different pieces of software, and other things that come in there to show a digital twin of a factory ecosystem. And this one here is showing the digital twin. So the left shows you the digital diagram, the right-hand side shows you the real world. And as you can see, you can build a complete replica of what your production line is going to look like before you actually go build it, which means incredibly efficiency. Now you add a couple more examples. This is Delta, which is a memory company. And again, you can see the left-hand side shows the digital replica, the right-hand side shows the real world. And the final example, this is Wistron, another manufacturing site. And again, digital twin in the real world. So this concept of bringing AI and then bringing in this concept of digital twins is really going to revolutionize business in many ways that people didn't think possible. So let's look back at this concept of Gen AI, and let's go beyond the hype. So 2022, November 2022, is what we call the iPhone moment of AI. Right? The launch of ChatGPT. And it's interesting because things like ChatGPT is seriously threatening the existence of things like Google. Because the reality says, you know, if I use a search engine to go and do things, why these days, most of my kids in their 20s, they don't use Google at all. They use ChatGPT for everything. They go in there, they put the request in, they get the answer they want. Now, so through 2023 into 2023, it was allowed people trying to explore what they could do with large language models and RAG proof of concepts, retrieval augmented generation of responses. And lots of sort of pilots that were going on in that time, lots of industries, lots of startups, everybody was looking about how they can use this technology in the real world. 2023 was then also for customers asking, how do I keep up with the pace of innovation? Now, an interesting part, in my house I have a central heating system, I have a maintenance contract with a company that comes around once a year to maintain my boiler and my heating system and everything else. Now, when that guy comes round, he comes around with a laptop today, and he doesn't have any clue what my boiler is until he gets there, even though they know what it is. It's on maintenance. The guy turns up and goes, oh, you've got one of these. Looks up, tries to find the CD that he has in his little pack or whatever, which tells him which model it is. And if he gets that to work, then he's on the phone, I need to order a part, and it takes him like half an hour to get through with no mobile signal in a rural area, trying to make sure he can order his part. With ChatGPT, he can go there and say, hey, I've just arrived on site. It's a Worcester Bosch boiler B52 1999 model. And ChatGPT can go, or a model of ChatGPT can go, okay, here's all the manuals. What would you like? Do you want the service manual? Do you want the maintenance manual? Do you want the parts list? And the guy can go, I need to order a new heat exchanger. And he can literally go, okay, click. The guy goes, okay, this is the part you need. I'll order it for you. That is going to revolutionize things like that in the business way. And that's how people are starting to look at, how can I keep up with this pace of innovation to transform my business? 24 and 25 is all about people going into production. And like I said, the interesting thing is people think that we have seen this huge surge in the demand, huge surge in the marketplace. NVIDIA's seen a huge surge in our stock price. Thank you very much for that. It's really good for me. But we expect that to continue through 2024 and 2025 and beyond as people start to move some of these technologies and models into production. It really is going to revolutionize almost everything you do. And some of the things that we're starting to see people look at in these proof of concepts they've been looking at in the enterprise world is in 3 or 4 areas. One is this concept, the intelligent chatbot, the example I just gave you, the heating engineer. There are also people looking at things like having a knowledge-based code pilot And then the third thing, as I said earlier, is how can I get code generation done more efficiently? How can I re-engineer my business with new applications and everything else? Now, the other interesting side of this is a survey was done recently that showed that 68% of AI projects are likely to be done in-house, not in the cloud. Now, part of the reason for that is people are starting to recognize if I put it into a cloud environment, then I have a challenge because I'm losing control of all of my data, all of my business is not there anymore. It's not like me going to use Workday to manage my HR or using finances in the cloud. I'm taking my entire company effectively becomes run by AI in lots of areas. I'm not sure I want to put that in the cloud. The challenge with that is most data centers in the commercial world have performances of about 12 kilowatts a rack. And you're going to get to build a generative AI system, you're going to be like 100 kilowatts a rack. So there's going to be a lot of demand for co-location services rather than cloud services, where I think people will take their platform and host it in the country or local to where they are, rather than necessarily going and putting it into a cloud environment. So there's some key customer challenges coming up, and as your previous speaker mentioned, the leakage of domain IP is something that's really important to people. People are really concerned about that, their brand alignment, making sure secure data access, portability and ownership, and how can I get my POC into production. And these will be things that most enterprises are going to be looking at and thinking about in the next 12 months to 18 months. If they're not thinking about it, they won't be in business in 18 months, in my view. They're really going to struggle to compete with people who've made the investment. Now, one of the things that NVIDIA's done is we've announced earlier this year, we announced this concept called the NVIDIA Inference Microservices. These are pre-trained AI models that basically enable you to design and with AIs and everything else, you can go and build a model really, really quickly. And it runs super efficiently on any GPU. You can go back to GPUs from 4 generations ago and still run the same microservices on them. So it's backwards compatible, and you've got that install base of hundreds of millions of NVIDIA GPUs out there that can be reused to deliver AI microservices. So it's not about going out there and completely replacing all your estate. You can reuse what you have. And lots of models and things around that today will have to happen. You're going to see a lot more announcement on NIMs from NVIDIA coming up in the next 2 or 3 years. We're building blueprints to how to enable people to build any application you want. So you can basically start and get an application built in hours rather than months. Now, the final part of my presentation, obviously there has to be a little bit of a product announcement, and we recently announced our Blackwell GPU, which is our latest GPU. It is an AI super chip with 208 billion transistors. It has a big transformer engine. One of the things you'll notice when you look at AI workloads is as it moves towards inference away from training, people want to go to lower and lower precisions. So we're getting increasingly driven to FP4 and FP8 rather than FP64 that's more used in intense numerical combinations. And so we're starting to see a big move in that way. Secure AI, our 5th generation of NVLink, big RAS engine, and other things around that. Now what that means in reality is that we have this new platform to do trillion parameter scale generative AI. Like I said, all the things that go with it. This is an example of our board. It's 1 CPU, 2 GPUs built onto a single board. And then you scale that up, and this gives you the example of where you are going to be with this. So this is showing the Intel, wash my mouth up. Sorry, Claudio. NVIDIA's history, when you go from Pascal through to Blackwell, you can see there's a huge difference in terms of the energy reduction in 8 years, but also 1000x AI compute over the same period, which you see this huge spike now. As you go to FP4, FP8, with the Blackwell generation, you've got a massive improvement in the AI performances coming out of the technology. We have this new NVLink switch chip, which is really exciting. It's chips. And I used to have an old friend of mine who was a software guy to say to me, why do you hardware guys always show pictures of bricks? Right? And he said, that's just a brick in it, really. And I make the point he means, but this is the glue that holds everything together. This gives us the capability to now scale GPUs, 72 GPUs into a single entity with one shared memory across the 72 GPUs, which is going to give you massive performance for large language models and for inference workloads. I've got three seconds left according to my timer, so I'm going to be about 2 minutes overrun. You have to excuse me. So as I said, we've come to this concept of the GB200 NBL72, which is 72 GPUs in a rack. It requires 120 kilowatts of power to power it, and it's liquid cooled. So that's a big challenge already for a lot of the colo centers out there, and they don't have that power per rack. They said the average enterprise is 12 kilowatts a rack, and they don't have the liquid cooling. But having said that, this product is sold out the next 6 months. So somebody's finding places to put it and going to drive it. But the real thing this drives to you is it gives you a massive capability to scale workloads even higher by having all of those GPUs networked together as a single entity. Now, final slide from me, and then I'm going to wrap up. I'll be 1 minute over, so not too bad. Previous generation has been our Hopper generation. And as you notice from NVIDIA slides, what you'll see is we look at 4 or 5 different things. We have the GPU at the top. We have the CPU. We have the MB link switch, which is the glue that holds it together. Then we have the NICs to do the networking, and the switch-based technology, the InfiniBand or Ethernet. This was our Hopper generation, been shipping now for a couple of years. We announced the Blackwell platform, which is going to be shipping in the beginning of next year, with all new, everything that goes with it, new Ethernet switches, new InfiniBand switches, new NICs, new switch, new GPU. We're going to announce enhancements to that in both areas that are coming out later into the end of 2025. And then in 2026, we have a whole new platform. We have our Vera CPU, we have our Vera GPU, a Rubin GPU, and we have other things to come as you can see it. So with a data center scale, we're looking at now producing new technology every year. Now, everything is backwards compatible, but we're having to do this because we're being driven by the pace of innovation and customer demands that are going to drive us that way. Full picture. And the final message from me, really, from NVIDIA is, we don't really care how you consume this. You can consume it by cloud, you consume it on premise, and here's a selection where you go. We're in all of the major hyperscalers. We're in lots and lots of different software companies that are out there. And at the bottom of this, obviously, we have a network of partners around the world help us deliver this, including Equatro, who obviously does a fantastic job for us in Europe and is a very, very strong partner of ours in enabling this, and has been one of the visionaries behind driving AI amongst our partners for the last 7 years. So that's everything for me. Grazie tutti. Thank you.